When developing, there are times when you need to work on multiple tasks simultaneously. This includes developing various features for the next version, performing refactoring to improve the code, or urgently fixing and deploying a bug. In these cases, each task should not affect the others. In this lecture, we'll learn about branches, which provide independent workspaces. By end of this lecture, you will understand what a branch is, how it is implemented, and the role of head. Let's get started. In development, there are instances when you need to separate your work. This can happen when you are developing multiple features for the next version, performing code refactoring to improve it, or urgently fixing and deploying a bug. Each task should not affect the others. In other words, a feature developed for the next version should not certainly be included in a version released as a hotfix. How can we ensure such independent development? Do we need to create and use multiple working directories? No, we do not. Using branches in Git allows you to develop independently without affecting other tasks. This illustration shows the concept of branches. Currently, there is a branch called master. The master branch contains the content that has been previously deployed. To develop features for the next version, you create a new branch from the master branch called develop and proceed with your work on this new branch. At this point, imagine a critical issue arises in a previously released version while you are developing a new feature. This requires an urgent fix and immediate redeployment. So, how should you handle this situation? If you make these changes directly in the develop branch and continue working on the fix there, the unfinished in-progress code from ongoing developments will also be included in the hotfix release. This is something we absolutely want to avoid. In such cases, since the last version we released points to the commit on the master branch, we can create a new branch called hotfix from here. By doing so, we can make the necessary changes for the hotfix and create a commit that reflects these changes. This way, we can deploy only the content of the hotfix branch without including the changes made in the develop branch. By using branches in this manner, you can work on multiple tasks independently. This diagram represents an abstracted commit history. As you can see, there are 3 boxes. Each box in the diagram represents a commit. The text outside the boxes indicates the commit hashes. The graph-like image inside the boxes represents the snapshot that the commit points to, essentially an abstraction of files and folders. Here, the commit is being pointed to by the text labeled master. This master is the name of a branch. This branch is structured to reference a specific commit in this way. I've already explained the definition of a branch. A branch is essentially a pointer to a specific commit. In this diagram, you can see the result of using a git command to list the branches. According to the output, there are 7 branches in this repository. When you create a branch in Git, it doesn't involve any special operations like changing the working directory or making new commits. What actually happens is that a file is created that points to the commit hash. Shall we verify this? This illustration shows the branches stored inside the .git directory. As you can see from the terminal command output on the left, the list of branch names displayed matches the list of file names stored within the .git directory. Additionally, you will notice that these files commonly have a size of 41 bytes. If we examine the contents of the file named subscriptions, you will find 40 character hashes stored inside. This pattern is consistent across other files as well, where each file contains a 40-character hash. You might be wondering why the hash is 40 characters, but the file size shows as 41 bytes. Where did the extra byte comes from? The additional byte is due to a new line character appended at the end of the hash. You cannot see it here, but there is a new line character that takes up 1 byte. So the branch file is actually 41 bytes in size. A file of 41 bytes is quite small. The small size means that creating a branch is an almost instantaneous low-cost operation. As a result, you can quickly and affordably create multiple branches as needed. Previously, we learned that a branch is essentially a pointer that references a specific commit. In this diagram, you will see that our current commit history has a branch named master. This branch points to a commit with a hash 44BDE7A. Now, let's create a new branch named subscriptions that points to the same commit hash as master. At this stage, if we were to generate a new commit, which branch would this commit belong to, master or subscriptions? In other words, how do we differentiate which branch is currently active? Multiple branches can point to the same commit. So, how can we identify the current branch in use? The currently used branch is identified by reference head. Typically, head points to the most recent commit of the current branch. In this diagram, head points to the master branch, indicating that the current branch is master. If you change the current branch from master to subscriptions, you can see that head changes from master to subscriptions. How will a new commit affect the branches? In this commit history, there are two branches, master and subscriptions, and the current branch is subscriptions. When you create a new commit, it is added to the commit history, and the currently active branch is updated to the point to this new commit. Here, we can extend our previous definition of a branch. Initially, we defined a branch as a pointer to a specific commit. Now, whenever a new commit is created, the branch updates to reference this new commit. Therefore, we can think of a branch as a moving pointer to a specific commit. In this way, every time a new commit is generated, the branch automatically updates the hash it points to. Thus, a branch can be defined as a pointer that keeps track of the commits. The created branch can be renamed or deleted. When a branch is changed, is it simply that the branch's pointed commit and head are updated? Is there nothing else happening? This diagram represents the object database and the working directory. The current branch in use is the master branch. At this time, if there were no additional modifications in the working directory, the content of the working directory would be the same as that of the master branch. In other words, the content of the current branch and the working directory are identical. If you switch the branch you are currently using, the working directory will reflect the state of the branch you switched to. For example, I have now switched the branch from master to subscription. Upon switching, you can observe that the contents of the working directory, which were identical to the master branch, have now been updated to reflect the subscription branch. In summary, you can understand that the working directory always reflects the state of the currently active branch. This concludes our discussion on branches. Let's practice working with branches in terminal. First, let's check the status of our repository. We will use the git log command to display the log in a single line and output it in a graph format. When you execute this command, you'll be able to see the current commit history and the list of branches. In the commit history, branches are represented as green text. The branch you are currently on is indicated by a pointer labeled head. Currently, the head pointer is pointing to the channels branch, which tells us that we are on the channels branch. Do you remember why we use branches? Branches provide an independent development environment. This allows you to continue adding changes without affecting other branches. For instance, if you are developing on the thumbnails branch, new commits will only apply to this branch and won't impact any others. Conversely, when you are working on the subscriptions branch, you can see that changes are made independently without affecting other branches. Using branches in this manner allows for isolated development, enabling you to manage your changes and updates more efficiently. To view the branches currently created in your repository, you can use the Git Branch command. This command will display a list of all branches registered in the repository. The branch you are currently using will be marked with an asterisk and the branch name will be highlighted in green. For instance, the current branch in use is named Channels. Before we dive into practicing branching commands, let's take a moment to understand how branches are stored in Git. I have opened an additional terminal window for this purpose. By using the ls command, you can see the .git directory, which represents the Git repository. Let's navigate into it. Once inside the .git directory, you will find a subdirectory named refs, short for references. Let's move into the refs directory. Inside the refs, there's another subdirectory called has. Moving into has and listing its contents using the ls command, you will see the branches that are currently in use. Clearing the screen and listing the files again, we can observe that within the .git refs has directory, there are 7 files. Each of these files corresponds to a branch, and notably the file size of each branch reference is uniformly 41 bytes. Here, we can see 7 files have been saved. Let's move over to the terminal window on the right. If you execute the Git Branch command, you will see a list of 7 branches which align with the files stored in the .git references head directory. Adding the free option to the Git Branch command gives us more detailed information about each branch. As you might recall, a branch is defined as a movable pointer to a specific commit. By using Git Branch -v, we get the branch names along with the commit hashes they point to, as well as the commit messages. This command confirms that each branch points to different commits. To verify which commits these branches actually point to, we need to check the contents of these files in the left window. As mentioned before, each branch file contains the hash of the commit it points to. Let's first examine the contents of the channels branch file. By using the cat command, we can see that the channels file contains a hash starting with A5FDFB. Referring back to the right window, we see that channels branch indeed points to a commit with this hash. Shall we check one more branch? Let's look at the mass branch. Opening the mass file reveals it contains a hash starting with 6F0C. Cross-referencing this with the right window shows that the hash in the mass file matches the commit hash that the master branch points to. This confirms that branch files are made up of 41-byte files holding the commit hash to which the branch refers. Right. Now, let's close the left window. So far, we've looked at how branches are implemented in Git and what information they contain. Next, let's take a look at some additional Git branch commands. Up until now, we've only used the command to list the currently created branches. But there might be times when you want to create a new branch. In such cases, you will use the Git Branch command. Let's try creating a branch named my first branch. When you do this, it creates a branch pointing to the same commit as the one to which the header is currently pointing to. So, if you type git branch, you will see that a third branch named my first branch has been created. Let's hit git log to check it out. You'll notice that my first branch points to the same commit as the branch channels, which is where our header is currently pointing. Right now, we are using the channels branch. As we discussed earlier, you can determine which branch you are currently on by looking at the head pointer. Presently, the working branch is channels, but we've just created a new branch named my first branch. To switch it to a different branch, you use the git checkout command. By typing git checkout followed by the branch name such as my first branch, you will switch it to that branch. You will see a message confirming that switch, and running git log will show that the head is now pointing to my first branch. Adding commits in this state will add new commits to my first branch. So far, we've been creating branches and then switching to them with separate commands. However, if you'd like to create and switch it to a branch in a single step, you can use the git checkout-b command. For example, typing git checkout-b my second branch will create and switch it to the branch named my second branch immediately. Let's execute this command. Upon doing so, you will see the confirmation message switched to a new branch. This means a new branch called my second branch has been created and you have switched to it. If you check the branch list, you will see that my second branch has been created and it points to the same commits as the header. Since we used the -b option with git checkout, it confirms that my second branch is now the current working branch immediately after its creation. Alright, once you've created a branch, you might want to delete it someday. Let's go ahead and delete one of the branches we've created. The command to delete a branch is git branch -d. You just need to type the branch name you wish to delete after this command. Let's go ahead and delete the branch we created initially. Type git branch -d my first branch and it will confirm the branch has been deleted. To verify, let's view the list of branches. As you can see, the branch named my first branch no longer appears in the list. Sometimes, you may want to rename an existing branch. To do this, use the git branch -m option. Let's rename the current branch from my second branch to my old branch. After renaming, if you run the git branch command, you will see that the name my second branch has been changed to my old branch. So far, we've explored how branches are implemented in Git, how to view branches, create them, switch between branches, rename them, and delete them. Lastly, let's practice something we've mentioned before. Branches operate like moving pointers. I explained that when a new commit is created, the branch will automatically point to this new commit. Now, we are going to put this to test by creating a new commit and observing if the branch pointer updates accordingly. Currently, we are using a branch named my old branch. This branch points to a commit that starts with A5FD. Let's modify a file to see in action. I will open up a text editor and make changes to a file named search. After making and saving the changes, we can return to the terminal and run git status to confirm that search file has been modified. Now, we need to add these changes to the staging area and commit them. Before doing that, remember that the current commit hash pointed to by our branches start with A5FD. Let's proceed and create a new commit. Once the commit is made, We will inspect the branch's state to see if the pointer has been updated. Upon checking, we can see that the myOldBranch pointer has indeed moved to the new commit, which now starts with F47DAE. This confirms that the branch pointer updates with each new commit, just as we discussed. If you compare these changes, you will notice that something has changed. When you look at Git log, you can see that the old branch, myOldBranch, was pointing to this previous commit, but after creating a new commit, the branch now points to the newly created commit. In summary, a branch points to a specific commit, and each time a new commit is created, the branch automatically updates to points to the new commit. This concludes our practice with branches in Git. Let's practice the branch concepts we learned in theory using SourceTree. First, let's check the status of the repository. Here is the commit history of the repository. As you can see in the commit history, there are branches diverging from the added channels update commit. These are the branches. Based on this commit, branches like videos, thumbnails, subscriptions, and search have been created, allowing for independent development on each branch. As you can see, there are no intersections between branches in the commit history graph, confirming that each branch is being developed independently. You can also check the list of branches created in the repository from the left sidebar. Here, you can see a total of 7 branches. When you select a branch, it automatically navigates to the most recent commit of that branch in the commit history. You can also filter the commit history to view specific branches. For instance, if you want to display on the current branch, you can filter it by selecting Current Branch, which will show only the history of the currently used branch channels in the commit history. In SourceTree, the currently active branch is indicated by a circle in the sidebar, and the branch name is displayed in bold font. If you want to view the commit history of a different non-active branch, you can select that particular branch to see its specific contents. Let's go back to viewing all branches. When you look at the full view, you will see the commit history presented like this. Do you remember the definition of a branch? A branch is a movable pointer to a specific commit. The branch contains the commit's hash. Let's take a look to see if the actual branch contains the commit's hash. Here is the content of the working directory. By viewing hidden files in Finder, you can see the contents of the Git repository. Branches are stored in the .git directory within the refs directory inside the heads directory. In SourceTree, you can observe that the branch list names such as channels, master, and playlist correspond with the file names stored in the heads directory. This is because the branch names are used as the file names. Let's take a closer look at the contents. When we open the channels file, we can see a hash stored inside. The file I opened is the channels file, and its contents starts with A5FD. By checking in SourceTree, we can confirm that the commit pointed to by the channels branch begins with the same A5FD hash. If you look below, you will find the full hash of the commit. Let's copy this hash and paste it here. When we copy and paste it, we can see that the hash from the file and the full hash in SourceTree are identical, confirming that they refer to the same commit. Now, let's open the master file. When you open the file, you will note that it contains the hash 6F0C. If we look at master branch, we can see this same hash 6F0C. Let's copy it for reference. You can observe that the hash 6F0C is stored. By verifying this, we've confirmed that the branch is a 41-byte file that stores the hash of the commit it points to. This demonstrates how branches in Git reference specific commit through their hashes. So far, we've reviewed how branches are implemented. Now, let's switch back to SourceTree to create a branch. To create a branch, start by selecting the commit that the new branch will point to. I'll be creating a branch here. Right-click and you will see a menu item called Branch. Select that menu item. Now, you need to name the branch. I will name it My First Branch. Once you've named it, you will see some options. One of these options allows you to create a branch pointing to this specific commit. Another option is to switch it to the new branch immediately after creating it. Let's go ahead and create the branch. After creating the branch, you will see that My First Branch has been generated and is now marked as the current branch. If you look at the commit history, you will notice that the newly created branch points to the same commit as the channel's branch. As you can see, creating a branch is quite straightforward. If you want to change the name of branch you've created, simply right-click on it in the sidebar, and you will see a menu option labeled Rename. When you select Rename, the current branch name will be displayed. You can then change the name and press the OK button to update the branch name. To delete a branch, start by selecting the branch you want to remove from the sidebar. Right-click on the branch and you will see the command to delete it. Select this command. A pop-up will appear asking for confirmation. Simply click OK to proceed with the deletion. However, there might be instances where an error occurs, preventing you from deleting a branch because it hasn't been fully merged. In such cases, you can first delete the branch. Let's take an example where we want to delete an old branch. Select the old branch, then choose the first delete option. By doing so, you can delete the branch regardless of whether its contents have been merged elsewhere. Check the first delete option and click OK to delete the branch. Once deleted, you will see that the My Old branch, which was pointing to the same commit as channels, has now been removed. So far, we have explored how branches are implemented in Git, as well as how to check, create, delete, and rename branches in SourceTree. Let's summarize what we have learned in this lecture. A branch allows for independent work. A branch is a named reference that points to a specific commit. A branch is a 41-byte file that stores the commit hash and a new line character. Have identifies which branch is currently being used and what the latest commit on that branch is. When you change branches, head is updated and the contents of the working directory change to reflect the new branch. When a new commit is created on a branch, the branch automatically points to the new commit. After creating a branch, you can rename it or delete it. Thank you for your hard work. This concludes our lecture. Through this lecture, you have learned Git branches. Now, feel free to create branches as needed and develop independently whenever you require. If there's anything you didn't understand from the content, feel free to ask anytime. See you next time. Goodbye.